Hey everyone, so here's part 3 of our lesson 6 notes. So now what we're going to discuss is what is a binomial experiment. So basically the example that we just did, okay, that is what we call a binomial experiment. Now, how do we know something is a binomial experiment? Well, there are 4 conditions that need to be met. And so to remember these 4 conditions, we kind of use a short phrase, BINS, to remember. So first, be binary. So basically the experiment has to be binary. There has to be success, there has to be failure. Okay, just 2 options basically. There can only, I should say, be 2 options. If you have more than 2 options or there's just 1 option, then it's not a binary or binomial experiment, okay? Because it's not binary. So for example, when we did the penalty kicks, that was binary because either they made the penalty kick or they missed the penalty kick. So there was 2 options, success or failure. Now, I means independent. So we talked about this and they did tell us, so independent means previous event doesn't affect the next event. So the probability of doing the first event doesn't affect the probability of the next event. So in our penalty kicks, they told us that the events were independent. So making the shot first does not affect if we make the shot second or if we do or do not make the shot the second time and vice versa. Okay, so it is all the events are independent. There's a fixed number of trials. Okay, so what we did for the penalty kicks, there was a fixed number of trials. They only had 5 kicks to do total. So our N value for that was 5. Lastly, S means same probability of success each time. So in our penalty kicks example, each success was 70%. So it was 70% of getting the penalty kick, and that stayed the same the entire time. It did not change. So if all 4 of these conditions are met, that means an experiment is a binomial experiment. Now, the formula we can use to determine the probability is this. So P, that means probability, X equals K. So K is just the number, right, of successes we want. So then we have N combinations of K times P to the K power times 1 minus P to the N minus K power. We actually solved this formula when we were calculating the number or the probability of getting exactly 4 out of 5 penalty kicks in the last example. Now let's talk about what does each of these variables represent. So remember, N is the total number of trials. I'm going to put input here, total. So total number of trials, okay? So like in the last example, 5 would be our total number of trials because we had 5 penalty kicks. P is the probability of success. So in our last example with the penalty kicks, our P would be 0.7 because that was the probability of getting a penalty kick. K is the number of successes. So like for example, K could have been 5 or it could have been 4. So we talked about how we could get all 5 penalty kicks or if we got exactly 4 out of the 5. So we could have done 4 or 5 as our K value. And then 1 minus P is the probability of failure, okay? So we talked about how there was a 70% chance or 0.7 chance of getting the penalty kick. If we miss the shot, that was 30% or 0.3. Now you may be wondering what's N minus K? Well, this is the number of times that we fail, okay? So it's the number of times that we fail. So for example, when we said, hey, we get exactly 4 penalty kicks, but we missed one, we said 1 would be our exponent here because we missed one of the goals. Okay, so now we're going to do a 4th part, and in this 4th part, we're going to do another example where we're doing a binomial experiment. So make sure you have all of this written down on your notes. If you need to, pause the video if you have not already done so to get this down, but make sure you watch the next video.